What hides inside the wind? Even after reading the novel The Inner Side of the Wind by Miloradovich, you're unlikely to come close to understanding what kind of absolute power the wind has. It's able to tear off roofs, turn houses into piles of debris, and toss trees in all directions. But what if a hurricane or typhoon is only the surface of the destructive elements? What if it's just a warning of another disaster that will soon impact the same region? In May 2013, northern Italy recorded an earthquake of magnitude 3.8. Almost simultaneously, a very strong hurricane gust of wind hit the same area. Experts were surprised at such a coincidence. But was it really a coincidence? Albert Einstein, paraphrasing the ancient Greek philosopher Socrates, said, "The more I learn, the more I realize how much I don't know." Surprisingly, this idea is also relevant to modern scientists who most recently discovered a completely new geophysical phenomenon right under their noses, a hurricane earthquake. During a storm season, hurricanes transmit energy to the ocean in the form of strong waves that strike the shore and generate increased seismic activity. That sounds reasonable, yet it's strange that no one has revealed a connection between the phenomena before. Scientists have analyzed more than 12 years of seismic and oceanographic data from 2006 to 2019 and discovered more than 14,000 stormquakes that occurred in the waters off the coast of the United States, as well as Canada and the Gulf of Mexico. It turns out that the most powerful hurricanes of the Atlantic generate tremors with a magnitude of 3.5 on the ocean floor. Researchers cite the 2009 Atlantic hurricane bill as an illustrative example. A tropical storm first struck Newfoundland and then New England. When the winds reached hurricane force off the coast of New England and Nova Scotia, numerous seismic vibrations were generated by transcontinental surface waves. Similarly, Hurricane Ike in 2008 caused an earthquake in the Gulf of Mexico, while Hurricane Irene in 2011 did the same near the islands of the Bahamas off the coast of Florida. We called this phenomenon stormquakes, explains Wen Yuan Fan, a seismologist at the University of Florida. During the storm season, or when a strong nor'easter blows, the wind transfers energy to the ocean, raising huge waves, and these vibrations interact with the ocean bottom, generating powerful seismic activity. Stormquakes are possible not only in the Atlantic region, but also in other parts of the world, but they simply have not yet been recorded. Of course, strong quakes didn't just appear recently. They have always existed, but we simply haven't paid attention to them since they were considered to be seismic background noise. Stormquakes are a newly discovered geophysical phenomenon that involves the interaction of the atmosphere, the ocean, and the Earth's crust and is highly dependent on the topography of the seabed. According to geophysicists, the sources of underground tremors are most likely associated with the ocean shelf. Recall that the shelf is the flooded outskirts of the mainland. Based on the structure of the Earth's crust, the shelf is still part of the continent, but in fact is also the bottom of the ocean. The shelf can extend hundreds of miles from land. The water in the shelf zone is relatively shallow, and storm waves inflict powerful blows on the bottom. This vibration propagates through the continent and is captured by seismographs. Wen Yuan Fan admits, "We didn't even know about the existence of such a natural phenomenon." It's interesting that while mankind is trying to reach for the edges of the universe, we still don't notice some basic phenomenon here on Earth. But in truth, it can't be said that scientists didn't pay attention to the signs of this phenomenon before. In 2017, it was noticed that the splashing of waves on lakes can cause a microearthquake, weak and short-term seismic vibrations. A team of geologists led by Wang Yong from Yunnan University studied 6 different lakes ranging in size from 81 to 10,400 square miles. That's 210 to 27,000 square kilometers. The lakes that were studied are located in the USA, Canada, and China. Scientists found that the waves on lakes caused by the wind lead to ground vibrations with different frequencies. These signals are very weak and detected only in the zone adjacent to the lake within between 15.5 to 18.6 miles, or about 25 to 30 kilometers, from the coast. But sometimes the wind resembles a saboteur who quietly intervenes in the course of events and radically changes them. Did you know that the wind can move mountains in the literal sense? Indeed, hurricanes not only cause severe storms in the seas, but also seem to trigger even more dangerous events. The great provocateur changes the texture of the sea bottom and causes tsunamis. Scientist William Teague, specializing in the study of the ocean from the laboratory of Stennis Space Center, Mississippi, believes that hurricanes can collect and move large masses of sedimentary rocks on the ocean floor, and that this can cause tsunamis. The researcher provided geological evidence in favor of his hypothesis. He claims that thousands of years ago, an inexplicable tsunami hit the Gulf of Mexico with waves up to 50 feet, or 15 meters, high, sweeping over Texas. In 2004, scientists considered the consequences and causes of the tsunami caused by the devastating Hurricane Ivan. This was when giant waves up to 131 feet, or 40 meters, high crashed onto the shores of Jamaica, Grenada, and the U.S. states of Florida and Alabama. William Teague states, "The investigation of Hurricane Ivan is strong evidence that hurricanes can change underwater landscapes, causing tsunamis." Various indicators were studied at several points in the path of Hurricane Ivan. It turned out that a storm cleared the bottom of about 11.8 inches, or 30 centimeters, of sedimentary rock and moved millions of cubic meters of sand. Scientific evidence of the role of hurricanes in seismic events comes from all over the world. So, geophysicist Selwyn Sachs is convinced that typhoons trigger slow earthquakes in Taiwan, which last several hours or even days. The fact is that the island is constantly experiencing tectonic stress arising in the subduction zone of two lithospheric plates. Such tension in the southwest of Japan leads to violent earthquakes every 100 to 150 years, but not in Taiwan. The authors of the study believe that the reason for this is slower-moving earthquakes, gradually releasing underground stress over many hours, and typhoons coming from the Pacific Ocean trigger such earthquakes. In addition, hurricanes create landslides that surprise us like a time bomb. In seismically hazardous areas, due to landslides, stress cracks appear in rocks, causing subsequent deformation, which is essentially an earthquake. It seems that when it rains, it pours, and so we usually observe a chain reaction of natural disasters. Geophysicist Shimon Dowinski plans to provide compelling observations that demonstrate cascading relationships between tropical wet cyclones, landslides, and earthquakes. According to him, in Taiwan, in 85% of cases, large earthquakes with a magnitude of 6 or greater occurred within a few years after very large typhoons. Some researchers have gone even further, trying to figure out if there's a connection between hurricanes, earthquakes, and solar eclipses. A group of scientists from the Alatra International Public Movement are proving the direct connection between climatic events on Earth and the activity of the sun. Refinement of this calculation system will allow for the future prediction of nature's interactions, and that means taking measures in advance to prevent this or that natural phenomenon or, in the extreme case, of mitigating it or at least timely evacuating the population. There are already examples of incredible coincidences in history when a hurricane, an earthquake, and yet some additional natural disaster befell a region simultaneously or sequentially. But modern science is only beginning to develop a complete picture of the totality of these natural phenomena. We see only individual grains of sand, dimly guessing what part they play in a single hourglass mechanism. Like the novel The Inner Side of the Wind, built in the form of an hourglass, natural phenomena can be read from the beginning or from the end, but a true understanding of the whole will only come with time. The discovery of such a geophysical phenomenon as stormquakes despite all the advances in modern science, was able to catch scientists by surprise. And you, what do you think of the hidden destructive effects of hurricanes? Let us know in the comments and give us a thumbs up if you liked this episode. And remember to recommend us to your friends.